An amplifier receives a signal from some proximity sensors or any input source, and delivers an amplified version of the signal to any output dispositive or another amplifier stage. A voltage amplifier amplifies the voltage to increase the input signal voltage. On the other hand, power amplifies or big signal provide enough power to an output load to excite a horn or another power dispositive. The main characteristics of a power amplifier are circuit power efficiency. 2. The maximum amount of power that the circuit is able to hold up. And the last one is the coupling of impedance with the output dispositive. A method used to categorize amplifiers is my class. Today we're going to talk about the amplifier classes, which represent the amount of variation of the output signal in an operating cycle. A class A amplifier is that one which represents at its output a signal copy of the input, but amplified and without distortion. That means the signal varies over the 360 degrees of the cycle. Class A amplifier offers the advantage that the output signal doesn't appear to be distorted. However, its maximum performance is 25% and 50% when the load is fed by a transformer. Here we can see the simple fixed polarization circuit connection. The maximum gain will be obtained when the point Q is placed in the center of the line of charge. The maximum power dissipated in the load corresponds to the case where the input signal provoked that the work point run over the whole load line. That means maximum input voltage giving a peak-to-peak output signal. This power will be. It is also useful to know the power to dissipate the transistor to not exceed its specifications. For class A, the maximum dissipation of the transistor produced at rest that is. As the peak-to-peak voltage increases in the load, the power dissipated in the transistor decreases.
The class B amplifiers are based on when the polarization of the transistor is turned off with a DC source. The circuit is on off until it enters on AC signal, which will make that at the exit of the circuit a signal of half wave is obtained. If a full wave output signal is to be obtained, two amplifiers of power transistors must be positioned simultaneously with a positive wave configuration, so that a part of the circuit pushes off produce the positive half wave push, and the other part of the circuit generates the negative half wave pull. This way, you get a push-pull circuit configuration. This type of configuration allows the power transistor user a couple of handle the desired power of the load. In this way, it is shown that this configuration gives greater efficiency than a class A.
The class AB combines class A and B, taking advantage of its advantage, eliminating the distortion by crossing, and has good efficiency, although not as much as the B nor as linear as the A. This configuration eliminates suitable cross distortion. It also has the same configuration as class B with two output transistors, but has a polarization current following between the base terminals and the power supply like class A. Finally, class AB has the same push-pull system of class B, recognizing and supercharged, whereas it has an efficiency less than 100% and greater than 15%. Then you can observe important equations.